Here we are at our example 1 from our 4.6 set of notes. We're talking today about the quadratic formula. Now, there are reasons where this thing comes from, and if we had more time, we would have the opportunity to possibly talk about it in class. But the quadratic formula is something that you just have to know, and on top of that, you're going to be able to use in a lot of your later on classes. So pre-calc, especially AP calculus. So this is something that you're going to see a lot more in your future. Honors Algebra 2 does it. So today, you're just kind of seeing it for the first time. The formula looks really weird at first, but I promise as you start to play with it more and use it more, you're going to become more familiar with it, okay? So don't let it intimidate you, all right? So we have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a, okay? And again, in Honors Algebra 2, they'll talk about where this thing exactly comes from. It is a super handy formula, guys. The moral of the story is, suppose you're trying to solve for a quadratic, right? And all of those notes that we talked about with factoring, and there's some other ways too that we can solve for quadratics, but this is the ultimate fail-safe, okay? If you're like, I just have no idea how to solve this quadratic, x squared, this is what you can always use, the quadratic formula, okay? So this is definitely something huge. So the quadratic formula, there it is. And today we're going to be playing with it. So we're going to be, first of all, identifying our a, b, and c. A is 4, b is 11, and c is negative 20. So we're identifying our a, b, and c. And now what we're going to go ahead and do is plug those values in where they appropriately belong in the quadratic formula. So the opposite of b would be negative 11 plus or minus the square root of b squared, b is again 11 squared, minus 4 times a is 4, and c is negative 20. This is all over 2 times a, so 4. Okay? Now what we're going to go ahead and do is simplify this stuff up. And as a result, we would have x equals negative 11 plus or minus. In here we get the square root of 121. Negative 4 times negative 20, all this stuff, when you take the product of those, comes out to be positive 320. Okay? And now when you add those two values together, you get 441. And this denominator is actually still going to remain, actually, it's not a 2, it's supposed to be an 8. Okay? So next, what we're going to go ahead and do is simplify up this square root if you can. This is where good and garbage comes up. And so we end up with negative 11 plus or minus the square root of 441 actually comes out to be 21 all over 8. And now what we're going to go ahead and do is the positive version and the negative version. So what I mean by that is we're going to have negative 11 plus 21 over 8. And then negative 11 minus 21 over 8. And when we simplify these up, we have negative 11 plus 21 comes out to be positive 10 over 8, which simplifies down to be 5 fourths rather. Whereas for the green one, when we're taking the difference of those, we'd have negative 32 over 8, which comes out to be negative 4. So again, if you're like, I'm really stuck on this whole factoring thing, or maybe you get a question that's really hard, this is the ultimate failsafe, guys. Okay, so it is something you'll need to know for the future. I know this question looked a little intimidating just because some of the values. We're going to see some where a is a little bit smaller. But again, though, this is something you guys just have to know, okay? Take my word for that. Again, though, that is example 1 from our 4.6 set of notes.